everyone, welcome back. In this video today, I will talk about the new topic in pre-calculus Math 12, which is solving the radical equation algebraically and graphically. And we can compare both the solution and see how it works. Before I get into the lesson, let me talk a little bit about my course online. I have been developed the course online for 3 months for now, and my first introduction to calculus course 1 and course 2 has been published. So far, if you buy a bundle course, the price will be reduced by $80 US. So compare with the amount of my labor and on my effort to put it in to develop a course is very detailed, very well connected together. The conceptual and application, both of them, and very informative. With all the money I have to spend to buy for the course platform and on the marketing and spending, I can consider my work as the charity work, as the non-profit organization. Even though I charge you a little bit, not enough to get back to my budget spending for it, not even mention the labor and the effort I put in. If I didn't have to spend all of that, so maybe I could offer the course for free to all of you. But anyway, I hope that you will understand why I charge it a little bit. But I still think that I have contributed a lot into our global education. And my work so far can be considered as a non-profit organization. And I hope you will support me if you like my teaching from the YouTube you see and you need it. Regardless, you are an adult student, want to review the mathematics concept, or you are a fresh graduated from Math 12 high school and you need to take calculus in the university, or you could be an adult student or a grown-up person, have some interest in the topics I'm talking. My course serve well globally. So I think that because we are in the time of the digital revolution, and there never have been such a strong push for mathematics education across the globe, especially in our North America. Mathematics and advanced technology go very well together. However, the technology can be outdated, which is sometimes we not be able to catch up. But the mathematical concept and its core value never been outdated. And that's a good thing about the math. And I believe that our education online also an evolution in the future. Online education will be an evolution form of education to help all the students bring our gaps in inequality in education across the world together. So I believe that my work very important, and I have contributed a lot into our global education. Without the help of technology, YouTube and everything factors in there, I would never deny it and appreciate the development of high-tech evolution. However, I think that therefore mathematics education will be um, focusing for everyone. Um, if you want to go to the digital high tech and update with the change of in our society, I hope that on generation and parents start like um, uh, encourage or enforce students when at the young age, and because you have to learn math at the even though when you are at young age, so to see how you are good at it. uh, so I hope that um, the parents will realize how important mathematics is and to encourage their children to learn more and more in the mathematics area. um, In other words, I didn't say that other subjects are not as equally as important. However, with the change in high tech and dynamic of online education, um, I believe that math plays a very important role in our society from this day forward. In the past, we used to neglect this subject and um, we not encouraged to learn mathematics because we were thinking that it's too difficult or maybe too boring to look at it. Um, Not as beautiful as the poems or, like science and other um, language courses, arts and things. However, um, mathematics is for sure is very important from this day forward as well as in the future. So I encourage you to visit my mathteaching.ca and drop by to purchase my online courses. I develop my online courses in the way that is very well informed, very well connected together, a lot of details and informatics. And you can see from this video if you be patient enough to watch it. So let me get right into the topic. So yesterday I have shown you how to get the radical function based on its transformation and some basic features. So today we will learn, first I will show you in algebra how to solve radical equation in algebra first. And then the next video, I will show you both. We will look at both in the way of graphically and algebraically. So just bear with me 1 minute. So I'm going to have to change this topic here. I'm going to say this is about solve algebra equation. So solve radical equation. Radical equation. So for example, let's say we just start from a very simple algebra equation. You have an equation x plus 9 might equal 7. So this is the radical equation because we have an x value, the unknown number, in as a member inside the radical. And that's why we call it radical function or radical equation. Now we say equal because we have left side equal on the right side. So when anytime you have an equation like this, we can solve for a known number. Now, in terms of radical equation, we have to be careful a little bit because sometimes you solve it and you have an extraneous root, which is the root is not valid as one of your solution. Even though we solve it and we get it, but it could be a valid solution or it could be invalid. And therefore, usually we try to check after we solve and make sure we don't get an extraneous root as the answer. So first of all, what is the step to solve the radical equation? So the step involved, right? There's a couple of steps we have to look at it. Step number one will state the domain restriction, right? Domain restriction. That's the first step we do when we deal with solving radical equation. Step two will be, let me see. So we state the domain restriction. The step two will be solve, right? Solve the equation. And step three, check the solution. And it should always be this way because the radical equation is sometimes a little bit tricky. Now, for some basic one, maybe it's not so bad, but you will see how tricky it is later on. So this is just the simple equation. And sometimes you check your solution, you might end up with one root or two roots. So you might have one answer or you might have two answers sometimes. And sometimes both answers are working and sometimes only one of them is the right answer. And that's why we have to check it, right? Okay, so let's see. So let me focus on this and we're going to solve it. So solution. So I'm going to state the domain, right? So step one, so I'm going to perform exactly, right, what we do. X plus 9, we know that this expression cannot be less than 0. So we say X plus 9 got to be bigger equal than 0. I'm going to move it over. So X will be bigger equal minus 9. And this is the domain restriction. And we have to state this, right? So this is our domain restriction. Okay. So X have to be whatever our solution will be, have to be bigger than this number. Now let's solve for it. So that's step one. Now step two, we're going to solve. And the way we solve radical equation, we're going to try to get rid of the radical, right? Because that's the first step. We have to make it easy just to have an X instead of the square root of X. So how do we get rid of this radical sign? We will do square both sides, right? Because if we don't square both sides, how can we get rid of this? So we will have X plus 9, this is square root, equals 7. And we're going to have to square both sides. So now, because we square like that, so the root here is 2, the power here 2, will be cancel out each other, and the radical side will gone. So we were left with X plus 9 equals 7 to the power 2 is 49. Now, if we move it over, we'll get X equals 49 minus 9, which is 40. And here we, so our X will be, we power 2 square both sides. Yeah, so we have only one answer in this case, X equals 40. And if we have one answer, most of the case is the correct one. But let's say we still do the check step. So let's check. So the way we check, we will put in the left side and we will put in the right side. After we check if left side and right side, then we conclude that our solution is correctly. So I'm going to put in here we will say this is x plus 9 and this is 7. So our answer is 40. So we will substitute the x by 40. 40 at 9 is 49. And yes, square root of 49 is 7 equals 7. So it's okay, left side equal right side. It means this solution is working. It's okay. So that's how we do a simple one algebraically. Now we always start with simple, but it will go to more and more difficult, right? So let me show you another one. And when in this case, we have a extraneous root. So example 2, let's say we have the equation square root of x minus 4 equal 0. So this is the equation we have to solve. So before square both sides, I'm going to move this over. So I will have x minus 4 equal positive 4 because I moved over, negative become positive. So now to solve this, I got to square both sides. And this time I will have x minus 4 because the power 2 will cancel out with the root 2 and the radical gone. So we left with x minus 4 equal 4 squared will be 16. So now x will be equal, move this over, x will be equal 20 because when we move negative become positive, we add into 16, x equal 20. Again, we have only one solution. Okay, so let's check and see how it's going to work. Now, I'm going to put back into the original function, right? When we check it, we will check the original function. So this step will be step 2, will be checked. So I'm going to put here our left side and our right side. So now we will have an equation is x minus 4 outside. On the right side, we have 0. So now if we put it in here, we have 16 minus 4 because, oh, sorry, we have 20 minus 4, right? So our question will become 16 minus 4. And square root of 16 minus 4 is 4 minus 4 is 0. So 0 equals 0. That's good. So we don't have any extraneous roots in both cases. So maybe I have to look at another one to see how we're going to have an extraneous roots. Okay, so let's assume I will have to solve another example 3 equation, but this time my equation will be x minus 4. Instead of minus 4, it will be plus 4 equals 0. So obviously, all of this step we already solved, except that this is plus 4. So when we move it over, it will become minus 4. However, because we square both sides, so yes, everything will be stay the same, right? So therefore, our solution exactly the same way, because this is exactly the question, except that instead of this minus 4, we change into plus 4. So now, when we solve it, we know that because we square both sides, so minus 4 squared will become positive 16, and we end up with the same answer. So after we solve this one, right, we ended up. Okay, let's see how it works. So x minus 4 equals 16. Yeah, so 16 and 4 will be 20. So x still 20, right? So exactly the same. Now, when we check it, let's see if we check it. Let's say we perform the checking step now. So let's say if we check it, what happened? We have x plus 4 left side equal the right side supposed to be 0. So this time we will say square root of, minus 4. Square root 20 minus 4 plus 4. And that will give us square root of 16 plus 4. And it turned out 4 and 4 will be equal to 8. That is totally different from the right side equal 0. So in this case, the dynamic of just changing the sign from the same equation of radical equation, we perform exactly the same step, we get the same answer, but when we check it, we get different answer. A cannot be 0. So in this case, we say no solution. Because we only have one solution, but it's already wrong. So that's why in radical equation, when you solve for it, you got to be careful. Sometimes you might get the answer and you thought that you're so happy, you say, oh, x equals 20. You thought that's what, but when we check it, one is working, one is not working. And therefore, that is um, the extra task we have to do when we solve our radical equation. Usually, we already learn how to check our solution before, even though it's not radical equation, even though it's just linear equation or something. But we usually don't have to check because usually they are correct. But in radical equation, we must check the solution, even though we put in the restriction. So let's see what the restriction for this one. For this one, our restriction, let's talk about the example 2 here. The restriction here, we say x minus 4 have to be bigger than 0. So therefore, x have to be bigger than or equal 4. And when we answer x 20, that's okay. That's correctly. It's okay. We say x have to be bigger than or equal 4. We got x equal 20, so nothing wrong with that. And in case here, if we follow this restriction, we see, oh, obviously, based on the restriction we state, we see that nothing wrong with it. But we still have to make sure we do the number 3. So I mark here the start asterisk is very important, right? So even though we restrict the domain, it doesn't mean that it's not going wrong like this. So we have to be careful in solving radical equation. I hope that you enjoyed this video, and I'm going to make this video short. And in the next video, so stay tuned for our next video. In our next video, I will show you how to solve the radical equation, both algebraically and graphically. And we will decide which way is better and how it works, right? So I hope you enjoy my teaching video today. I go a little bit fast today because this topic is if you are at Math 12 level. Solving algebra equation is not a big deal. Understand its transformation concept, how to install, decide the value A and B and C transformation might be a little bit new to you, and this stuff checking may be a little bit new, but anything else is just normal algebra you have learned so far, all the way from elementary up to Math 12 level. So that's why in this case, I go a little bit faster. And I hope you enjoy my video. Bye for now and stay tuned for our next video.